the Sustainability Research Symposium. Here we are today in Wilson Library. Thank you all for coming. So we have a great array of speakers talking about a range of activities around Carolina's research enterprise. So when we began Sustainable Carolina, which is our sustainability initiative at the university, one of our goals was to intentionally couple our sustainability practice to the research enterprise of the university. So that doesn't mean that research is necessarily going to directly inform all the decisions we make, but it does mean that there are lots of important things going on at the university, obviously, many of which have application in the sustainability realm. So we began last year and had a great symposium, following it up this year with another one that we hope will be really good again, to draw attention to some of the amazing work going on and begin to look for bridges for ways that the work may or may not inform directly the things that we're doing around sustainability. So the first speaker needs no introduction because it's me. So I'm going to talk to you about a really overt example of coupling our research activities to sustainability. And just by coincidence, I'd like to say it was perfect planning, but 10 years ago, just about to the day, Energy Services here on campus funded a pilot project at the Institute of Marine Sciences where I was. And the lead on that project was geologist Tony Rodriguez, and the idea was to create habitats that sequestered carbon and help the university meet their goals to be carbon neutral. At that time it was 2050, now our goal is 2040. So, we will hear from 8 researchers. So I was looking at this last night and had already sent it to Melanie and realized that I missed a chance to say Carolina blue carbon. But by putting in the possessive, I didn't quite have it exactly on brand. But this is the coastal landwater margin. This is a place where I work an awful lot and have a huge affinity for. I think empirically gorgeous, but really complex and interesting. Tons of things going on with biology, with chemistry, with physics. And blue carbon is this idea that this fringe along the edge of the coast, connected to the ocean and the ocean itself, are places of huge processing of carbon. So they're really reactive and they're really likely to be storing a lot of carbon. So this is Tony Rodriguez's boat. I just wanted to let you know that IMS is the best place in the world, and that if you ever get a chance to go down there, you should. Absolutely delightful sampling in seagrass beds. The other point of this picture is that there's a lot of heterogeneity. This isn't a monolith, and when we talk about blue carbon, pretty often people make a lot of generalizations, and I'll talk very quickly in my short talk today about ways we might be able to improve that and challenges we might face when we make these generalizations. So carbon stocks. So blue carbon is this idea that there's this really reactive place and we have a chance to store carbon to our benefit, getting it out of the atmosphere, getting it locked down into the soils. But carbon stocks generally ignore spatial variability. So these are 4 cores that Tony's group took along a transect in a place called Jones Bay. And I'll overly simplify here and say that the dark areas tend to be organic and carbon rich. The gray areas tend to be sand and other things that have less carbon stored. So you can see as you look through these 4 cores how distinctive they are, where the peak in the dark area is, the magnitude of the dark area. So you can imagine if you're trying to understand what the stock is there, you need a lot of information to be able to say it correctly, to make a correct assessment. And more often people take one core and generalize it to the whole space. So again, back to the beautiful pictures of all the habitats, there's an awful lot of heterogeneity and the habitats behave differently. The other thing we're interested in is the rates of carbon accumulation. And they're really variable. There's a synthesis of a bunch of different rates. They're really variable by latitude. They're really variable by tidal setting. If you know anything about North Carolina's coasts, we have tidal range along the coast in the inland areas from just about 0 inside the Outer Banks in some places where it's just wind tide driven to more than 1 meter as you get south towards Wilmington. This affects carbon sequestration elevation. So as you move in, if it's a very flat area, it's going to be very different if it's a steeply sloped area. And then dominant haplotype. So what plants are there? There's huge variability from plant species to plant species and really within those species as well. All this to say, it's an exciting opportunity to store carbon in the coastal zone, but also a really complicated one that if you're going to account for it accurately, you need a lot of information. So again, another picture of Tony's great boat right there in the center. He also has drones, so he's able to capture himself from the sky, which is very appealing. This is something that a lot of us at IMS think a lot about. These dynamic margins, you can see, though not a video, you can see the sand in motion. You can imagine all of the movement of water, the biology, the geology interacting to create what you see here, which is this marshy area, but not one that is really homogeneous. And again, here we have on the left-hand side, a big oyster reef as well. So another habitat that we work a lot in, which I won't have time to talk about today. But oyster reefs potentially could be carbon sinks, but there's this challenge that some non-chemists forget, that when you create a mole of calcium carbonate, you also create a new mole of CO2. So that's something that people overlook for a while, and so there's this big it was a rush to adore oysters to fix everything. Carbon sequestration is a complicated one for them. So this is the Institute of Marine Sciences. Not necessarily completely conventionally beautiful, but highly functional, and it has an awesome shoreline, which you see in the top part of the figure here. This is an area of shoreline that is not beautiful, and for a very long time, though we were an organization that focused on the environment and trying to make things work better, our shoreline was not fantastic. We had an opportunity through the funding that I mentioned. Oh no, which am I clicking on? Oh, wait, there we go. To create a better shoreline. So if you look at this, it's just riprap, it's pipes coming out. But with this money, we were able to install a shoreline that included oyster reefs, salt marsh behind it, and do so in a pretty quick manner. And this is a pilot scale project and allowed us to really look at the complexities and the challenges of what people talk about as green infrastructure or nature-based infrastructure, or whatever you want to call it, nature-inspired solutions. There are all kinds of words. But this was an awesome time, and exactly what you would hope we could be doing at the Institute of Marine Sciences, and that is doing pilot scale work while also informing, I won't necessarily say advancing because there are some challenges, but informing the university's sustainability efforts. So these series of oyster reefs were installed using oyster shell, which is the optimal material for settlement. And behind that, a bunch of salt marsh was installed. And it was highly successful. It weathered a couple of hurricanes, but this is an area that has a lot of boat traffic. And so in the end, it ended up moving a little bit. Whoa, how do I go forward? Sorry, I'll get it. All right, Melanie. I'm doing advanced and it's not doing it. Any ideas? I don't want to lose the...
Yeah. Mm-hmm. There.
Perfect. So you can see here a bunch of salt marsh, so it worked really well. But you can also see here that the oyster shell had begun to move, it continued to move, and so we're going to need to take additional actions to firm up this space. But the exciting news is we have this carbon inventory, we understand what's here. Funny story, over on the far right side out of frame was the first area that was of marsh that was planted by some middle school students about 16 years ago, including my oldest son, and that's the part that's thrived. And I think it's totally coincidence, but we love that. So what we found is that this sort of process can work and that it can be a non-trivial carbon sink, but also it really needs to be thought through in terms of context. So here we're in kind of a high wave energy area, and what we found is that additional interventions are going to be necessary. And so we're in a great spot to know what we've done that's good so far and to understand what else we can do to advance carbon sequestration, shoreline stabilization, its use as a research asset, all in the same place. So IMS, I think, is definitely an amazing asset. Everyone should go visit if you want to. And I think this is a really interesting example of coupling our research to our sustainability. Are there questions for me? I'll start right away. I have questions for you. Can anybody think of projects sort of like this? Obviously, it doesn't have to be about blue carbon, but thinking about the way that we consider water from a sustainability perspective, the way that we consider waste from a sustainability perspective, the way that we think about greenhouse gases. Can you think of any projects you wish would happen on campus that are kind of like this, nature-based things? I'll tell you one I wish. We have in the room the author of a really cool story about the origins of the streams underneath all of the university. What an asset that water is, and what an opportunity it would be to have meeting of the waters come to the surface in some places. So I think that sort of thing is a really exciting future prospect, and we should keep in mind that that we have assets here that we don't think of because some of them are underground in pipes. And yesterday, the cleanup was at the tiny little natural marsh area over by the Stone Center, or not marsh, stream. If you haven't visited it, you should go see it. Tony.
I will add to that and say that I think a really wonderful resource that Carolina has is the Mason Farm Biological Reserve. And it's currently really understudied, let's say. Not that I think we should all go like tromping around there and destroy it, but in conversations that I've had with the Nature Center, the word is escaping me, Botanical Gardens, there is a lot of like relic studies out there, but not currently a lot of active studies out there, and I think better understanding the resource that is there, especially from like a wetland standpoint and a connectivity to Jordan Lake standpoint, I think that's a place that we're not really thinking about much on when we're on campus.
Yeah, that's a great point, because it doesn't always have to be bringing something back. It can be really understanding and appreciating something that's already there. Yep. All right. Anything else that anyone would like to talk about? Again, please go to the coast. Institute of Marine Sciences. It's awesome. All right, Cindy.
The Carolina North property, I think, also offers a lot of opportunities for engaging in pilot projects of a variety of sorts.
That's absolutely right. And a couple years ago in the Sustainable Triangle Field site, that was our upstream most station in some monitoring that we did. And it's a remarkable opportunity to have a forest as opposed to a neighborhood, which is most of what we have in areas like this that are pretty developed. Yep. All right. Thank you all. So, next up. Very excited to have Lindsay Smith-Talley with us, who just joined our Sustainability Council, which is exciting and wonderful. She comes to us from the Gilley School of Public Health and also Carolina Population Center, one of our neighbors, which is fun for us